Hello students, welcome to this lecture number 12 on chemical equilibrium. In this lecture, we are going to discuss the impact of temperature and impact of inert gas and catalyst. In the previous lecture, we have discussed about when we are going to change the concentration at the equilibrium point, or when we change the pressure of the gaseous reaction, at that time what will happen to the equilibrium. Now in this lecture we will discuss the temperature, impact of temperature. So we can write this today's heading of this video, that is the impact of that is we are going to discuss the impact of temperature, then catalyst and inert gas. So these will be three factors that we are going to discuss in this lecture. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. When the equilibrium is disturbed by any factors that is basically governing the equilibrium, that at that time what is going to happen, that equilibrium mixture will be changed because of the fact that reaction quotient is changed. Reaction quotients always try to equal itself to the equilibrium constant, and at that time what is going to happen, the equilibrium constant and the reaction quotient are different with each other, and at that case only that equilibrium composition will be changed. When it will be depends on the reactions, which factor we have changed, that sometime it will in favor of the product, sometime it will be in favor of your reactant. But the equilibrium constant depends on the temperature. Means if we change the temperature, then equilibrium constant will going to be affected, and that will be governed by, or we can say that we can able to predict how the temperature is going to influence the equilibrium constant. That is from the Van 't Hoff equations. The Van 't Hoff equation says that this is a basic function of the Van 't Hoff equation. In this equation you can see there is a relationship has been framed, and you can see easily that the equilibrium constant is basically depend on this factor, that is the enthalpy change. So when del 0 is the enthalpy change of the reaction, enthalpy change. How this enthalpy change going to determine the temperature of the reaction with this equilibrium constant? Here you can see T2, at T2 temperature, the equilibrium constant is K2, and at T1 temperature equilibrium constant is K1, whereas T2 is greater than T1. So what is going to happen when del H is negative, means the reaction is exothermic. Suppose the reaction is exothermic. When this reaction is exothermic, then what is going to happen? This factor is going to be negative, that is log K2 by K1 will be less than 1. At that time, what we say, K2 is equal less than K1. Means at higher temperature, when the reaction is exothermic, then it will going to decrease the equilibrium constant. And that is what exactly happened for this reaction. This reaction is here, this is the exothermic reaction. And in this reaction, when we are going to increase the temperature, the equilibrium will shift to the left hand side. The reverse direction, the equilibrium net reaction will be goes on the reverse direction. It will favors the reactant, not the product. So when we increase the temperature for this synthesis of the ammonium, what is going to happen? The product concentration of product will be decreases, and at that case, what is going to happen? If we have to maintain the temperature of the reaction as minimum as possible, but to reach the equilibrium, it will take a longer time. That is why the catalyst has been employed in these reactions, in this exothermic reaction. So we can understand, when the reaction is exothermic, then when we change the temperature, we increase the temperature, the equilibrium constant is going to be decreases, and it will be detrimental to this reaction in terms of your yielding of the product. So for the exothermic reaction, when you increase the temperature, the reaction equilibrium constant will decreases, and it will decrease the concentration of the product. But when it is endothermic, endothermic means when enthalpy change is positive, means it is endothermic, right? It is endothermic. So in this case, what is going to happen if we take this formula, that is log K2 by K1 is less, it will be greater than 1. It will be greater than 1 because this factor will be positive when this del H0 enthalpy change is positive. Then we can say K2 is greater than K1. So when we change the temperature for the endothermic reaction, it will going to increase the equilibrium constant. Naturally, there will be the yielding of the higher product when we increase the temperature, because the reaction has been directed to the forward. Net reaction will be in the forward direction. So at that time you will find there is a increase in the equilibrium constant, means it will go in favor of the product and what is desired. Okay, so we can now understand how temperature is going to influence the equilibrium of a reaction, and that will be depend on the enthalpy change of the reaction. The enthalpy change is exothermic, means enthalpy change is negative. At that time, the equilibrium constant will be have a negative term when we increase the temperature, and this will going to decrease the concentration of the product. Okay, now we will have some numerical, some questions. Which type of questions it will going to come in your exam? This type of question may come in your exam, that is, increased temperature favors the forward reaction. The 4 reaction has been given. Among these 4 reactions, one of the reaction will have, when you increase the temperature, it will favors the forward reaction. And you have to identify which is that reaction. You can pause the video and do yourself, then we will understand. We will solve this. Here you can see, when we change the temperature, and it will further reaction will be proceed, and that will be only possible for those reactions where the enthalpy change is positive, means endothermic reaction. So you have to identify which reaction is endothermic, and if you understand, if you know which reaction, then you can able to do that. Take one, that is the first reaction, SO2 plus A2 and SO3. This will be the exothermic reaction. This also, conversion of the ozone to oxygen, it is also exothermic, and this reaction also exothermic reaction. But this reaction, when the graphite has been changed to the diamond, this reaction is endothermic. You have to give some energy, that will, why it will be changed to the diamond, and this reaction will favor the forward reaction for the increased temperature. Okay, this is a good example. In this example, you can see it has been given for which reaction the combination of high pressure and high temperature helpful in obtaining the high yields. That you have been given the 4 reactions. In this reaction, one of the reaction will have this, that is high pressure and high temperature, you will get the high yields. So you have to see this reaction very closely. Observe this reaction very closely. For the first A reaction, you can see it is a endothermic reaction, but here you can see the forward reaction, that number of moles in this reaction, the number of moles of the product, is less than numbers of mole of reactant, and it is endothermic. High temperature will give equilibrium constant will increase, but due to this factor, it will, when the high pressure, what is going to happen, the reaction will goes in the reverse direction. So here you will not get with high pressure and high temperature high yields. Here also this is a exothermic reaction. That is why with the increase of the temperature, the yielding will be low. This is also not possible. For this reaction, you can see here is the endothermic reaction, and as well also you can see there is a high temperature with a high pressure, that we will see that the higher is, because you can see in the reactant, in the number of moles of the product is less than the number of moles of the reactant. So in this case, you will found that there will be the high yields, because here 3 moles will produce the 2 moles. So reaction will, when we increase the pressure, the reaction will on the forward direction, and this is also a endothermic reaction. When you increase the temperature, equilibrium constant will increase, and that will going to give a good yield. Okay, this type of question will come. Right, now we are going to understand the impact of the inert gas. Now we are going to discuss the impact of the inert gas. Inert gas. When we apply inert gas at the constant volume, then there will be no change in the equilibrium. We can write at constant volume. At constant volume, no change. Equilibrium will remain as it is. No change in equilibrium. Okay. No change in equilibrium. Why no change? Because the partial pressure or the concentration of the reactants is not going to be changed because it is at a constant volume, and the inert gas do not react with the any other species. It will not take part in the reaction, so there will be no change. But if we add the constant pressure, if we put the inert gas at constant pressure, there shall be the probability of changing. There shall be the change, but that depends on the reaction. There shall be change, but that depends on the reaction. Two cases arises. Number one, where the total number of moles for this reaction, suppose this N2 plus A2O2 and it will be 2NO. In this reaction, if we change the pressure, if we make the pressure is at constant pressure, you can write at constant pressure, we have to make this pressure constant. That is why we have to increase the volume. So when I increase the volume, there is the probability of, not probability, there will be certainly the concentration of the reactant will going to be decreases. So if it is going to be decreases, then what is going to happen? There will be the probability of the equilibrium will be hampered. Okay, at that case you can see when for this reaction there is a reactant. When the reactant of number of moles of the reactant and number of moles in the product is same, at that time at the constant pressure there will be no change. But if this reaction is this, that is PCl5 and it will PCl3 and Cl2, at that time make the pressure constant. So increase in the volume will going to give the change in the reaction, and that time the forward reaction will on the process, because the reaction quotient you can see that will be changed, because in the concentration term, in the numerator there is a two concentration term, that is PCl3 and PCl2, and here in the numerator, in the denominator, it is the one concentration term. In the numerator, two concentration term. In the denominator, is it one concentration term. So when we change the concentration, then it will going to quotient will be less than the reaction equilibrium constant. So equilibrium will goes on the reverse direction. But if the number of moles at the product is less than the number of product moles in the reactant, then the reaction will goes on the reverse directions. So that is the change in the, when we add some inert gas in the reaction which is under the equilibrium, at that time this is going to be impacted. Okay. Now we are going to discuss, that is the impact of catalyst. How the impact of catalyst going to influence the equilibrium. See, the function of the catalyst is to increase the speed of the reaction, and it going to happen by re-engineering a low energy path that will helpful of conversion of the reactant in the product, and it will go through a transition stage, and this transition phase will have the same for the forward reaction and the backward reaction, and that will be both the forward reaction and the backward reaction will be impacted on that change, and the activation of energy will be lowered, and that will be at the same quantity, same amount for both the cases, that is in the reverse reaction and the backward reaction. That is why there will be no change in the equilibrium, but equilibrium will reach at a very lesser time. That will be the impact, but no impact on the equilibrium composition, equilibrium mixture will be there. Okay, and that is all for this video. In this lecture we have discussed about the impact of temperature, catalyst and the inert gas. Hope you like this video. If you like this video, you can share to your friends. I'm 100% sure that you will be benefited out of this, and whom you are going to share that they also. So that is all for today's video, and the next video we will start in the new topic, that is the ionic equilibrium. Till then, all the best and be best.